When I look at this system of equations, there are two things that I notice. The first one that jumps out at me is that they're not written in the same order. The first equation has t plus r equals constant, and the second one has r plus t equals constant. So they're not they don't have the variables in the same order. The second thing I notice is that the t's have the same coefficient, which means that I could probably solve this using elimination. So what I'm going to do is I'm going to rewrite the first equation with no changes, because just going to do 2t plus 5r equals 6. And the second equation I'm going to rewrite with no changes, except I'm going to switch the place of the 9r and the 2t, so that the equation has the t's lined up, the r's lined up, and the constants lined up. So normally, if I was going to solve this using elimination, I would have to have a positive 2t and a negative 2t, and I would add the two equations together. But it's totally possible for me to also solve by elimination by subtracting the two equations. I can subtract these two all the way down. Why am I allowed to do this? Why is it okay to subtract them? Well, subtracting them is the same thing as taking this second equation and multiplying everything in the equation by -1. And I'm allowed to multiply everything in an equation by whatever I feel like. The multiplication property of equality says I can do that. I can multiply the left side and the right side by whatever I want, as long as I do the same thing on both sides. So that would make the second equation a -2t minus 9r equals -22. And the top would be a 2t plus 5r equals 6. So now I've set this up where I can now add the two equations together and the t's will eliminate. I could probably just skip the step of multiplying everything by -1 and just subtract them right from the beginning. So multiplying everything by -1 and then adding will get me the exact same answer as if I look at these two equations and say, I'm just going to subtract these. I'm just going to subtract these two things. That'll give me the exact same answer. Because 2t minus 2t is 0. 5t minus 9r is -4r. And 6 minus 22 is -16. Which of course is the exact same answer I would get if I added these together. 2t plus -2t is 0, 5t plus -9r is -4r, and 6 plus -22 is -16. So multiplying everything by -1 and then adding is exactly the same thing as just subtracting everything. So if I just go straight to subtraction, I can save myself some writing. Regardless of the way you choose to do it, the next step is pretty clear. I use the division property of equality, and I learned that r equals 4. So there's half my answer right there. R is 4. Once I know the value of r, I then need to go find the value of t. And I've got several options for where I could plug in t. I could plug in t to either of the original two equations. Or if I wanted to, I could plug in t to this one where I multiplied everything by -1. And I don't recommend that because it's just chock full of negatives, and negatives make things more difficult for no reason. But you could if you really wanted to. Again, if you're trying to solve an equation in the most challenging way possible, you could use that all negative equation. I'm going to use the first equation though, the 2t plus 5r. 2t plus 5r equals 6. That's the one I'm going to use because it's got the smallest coefficients. There's no negatives. Again, no matter which one you plug it into, you will get the same answer. It will be correct no matter which equation you use, but I'm going to choose to use the easy one. So let's substitute 4 in place of r. Oops. And then we'll solve it. So 2t plus, and then 5 times 4 is 20. And then, as usual, we're 2 steps from the answer. I could divide first, since these are all even numbers, but let's stay consistent. Let's go ahead and use our subtraction property of equality first. dividing first would work here since it's all even numbers, but let's stick with what we know works. Subtraction and addition first, then division and multiplication. So here's the division property of equality. And we end up with t equals 7, negative 7, excuse me. Since this is not a xy problem, I don't necessarily have to write this as a coordinate. I suppose I could do 4, negative 7 for the answer, but I probably wouldn't write it that way because I don't know if 4 is the independent or dependent variable, so I don't know if it should be 4, negative 7 or negative 7, 4. I think it's probably okay just to write r equals 4 and t equals negative 7 for our answer. So I would say this is the preferred way to write your answer.